this lesson, I'm just going to show you how to solve the problem that was assigned in the previous lesson. This is the homework problem I assigned. It says, what is the new concentration if 100 milliliters of a 1.50 molar potassium chloride solution is diluted with 50 milliliters of water? So the way that I showed you in the example yesterday to solve this problem is you start with the concentration of the solution, whose concentration we know. And this isn't the only way to solve it, but it is a way to solve it. So we have 1.50 molar. Well, molar means there are 1.50 moles of potassium chloride in 1 liter of potassium chloride solution. Okay? What I explained yesterday is if you multiply this by the volume, it will leave you with just the moles. Now, in the problem, the volume is given to you in milliliters. The original volume of this solution here is 100 milliliters. And this is the KCl solution. But we can't cancel liters with milliliters. We've got to convert the milliliters into liters. And so what we need to know is that there are 1,000 milliliters in 1 liter. Okay, I want you to show me that on homework and tests and quizzes. Show me the equality statement that justifies building this conversion unit. So there are 1,000 milliliters. We'll put the 1,000 milliliters on the bottom so that I can cancel those liters, and the 1 liter on the top so that I cancel the milliliters and leave myself with liters here. But then those liters in turn are being canceled by these liters. So this cancels here. Milliliters cancel here. Now, it's important to know that KCl and KCl solution are treated like two separate things, okay? You can't cancel this KCl with this one because this is potassium chloride solution. But this cancels this, okay? So KCl solution here cancels KCl solution here. And we do this calculation, we end up with knowing what the moles of KCl are, or potassium chloride. 0.150 moles of potassium chloride. Okay? So what we're doing is we're adding more water to this solution, because it's the solution, the solvent in the solution is water anyway. If we write out just 1.50 molar potassium chloride and we don't say what the solvent is, because water is used so much, it's assumed and it's implied. It's supposed to be known that water is the solvent in a case like this. So when we add more water to it, we're expanding the amount of solvent. We're adding to the solvent, adding to the solution amount. So what we're going to do now is to add together what the original volume of the solution is and the amount of water that's being added, because that's going to increase the volume of the solution by the same amount. So we have 100 milliliters of this KCl solution. And we're going to add to that 50 milliliters of water. But this is just going to increase the amount of, or the volume of this solution to 150.0 milliliters of KCl solution. All right? So now we have moles and a new volume. And so we can calculate the new molarity for the new diluted solution. We're going to put it all back together again. So 0.150 moles of potassium chloride in this new solution, which has 150.0 milliliters of KCl solution. In order to make this into molarity, because remember, molarity or molar concentration is moles of solute over liters of solution, we need to convert this into liters. I'm going to put that, I'm going to multiply that by the 1,000 milliliters here. 1,000 milliliters over 1 liter, because I already have the equality statement there. Milliliters cancel out. And let's see, that comes out to be 1.00 moles KCl over liters of KCl solution, which is the same thing as molar concentration, KCl solution.